Development of a successful system. The System Development Life Cycle, SDLC, is a standard methodology for the development of an information system. It mainly consists of 4 phases: 1. System analysis, 2. System design, 3. System construction and implementation, 4. System support. Every phase consists of inputs, tasks, and outputs. Traditional SDLC was strictly sequential. The developers first complete the previous phase and then start the next phase. But now the concept of repository is introduced in SDLC, and it is known as a fast methodology where work is done across a shared repository. It means that all the inputs and outputs of phases must be stored in the repository. At any time, developers can backtrack to the previous phase, and they can also work on 2 phases simultaneously. For making a successful system, the following principles should be followed. 1. Both customers and developers should be involved for accuracy in the information. 2. A problem-solving approach should be adopted. The classic problem-solving approaches are: A. Study, understand the problem and its context. B. Define the requirements of a solutions. Identify candidate solutions and select the best solution. D. Design and implement the solution. Observe and evaluate the solution's impact and refine the solution accordingly. 3. Phases and activities should be established. 4. For consistent development of a system, some standards should be established. These standards are: A. Documentation standards, B. Quality standards, C. Automated tool standards. 5. Development of information system should be considered as capital investment. Cost effectiveness is defined as the result obtained by striking a balance between the cost of developing and operating an information system and the benefits derived from that system. Risk management is defined as the process of identifying, evaluating and controlling what might go wrong in a project before it becomes a threat to the successful completion of the project or implementation of the information system. At each checkpoint, the developers should consider the following options: A. Cancel the project if it is no longer feasible. B. Re-evaluates and adjusts the cost and schedule if project scope is to be increased. C. Reduce the scope if the project budget and schedule are frozen and not sufficient to cover all the project objectives. 6. Divide and conquer approach is the way of making a complex problem easier. In this approach, the larger problem, system, is divided into smaller problems. 7. For development of a successful system, the system should be designed for growth and change. When the system is implemented, it enters the operations and support stage of life cycle. Various approaches for development of information systems. 1. Model-driven. 2. Accelerated approach. 3. Joint application development. Structured analysis and design approach. Structured analysis is a development method for the analysis of existing manual systems or automated systems, leading to development of specifications for proposed system. The objective of structured analysis approach is to organize the tasks associated with requirement determination to provide an accurate and complete understanding of a current situation. The major tasks of structured system analysis approach are: 1. Preliminary investigation. 2. Problem analysis. 3. Requirement analysis. 4. Decision analysis. Structured analysis introduced a process modeling tool called the data flow diagram, used to illustrate business process requirements. Structured design utilizes graphic description and focuses on development of software specifications. The goal of structured design is to lead to development of programs consisting of functionally independent modules that perform relatively independently of one another. It is a specific program design technique, not a comprehensive design method. In structure chart, the whole application is divided into modules, and modules are designed according to some principles of design. These principles are: 1. Modularity and partitioning. Each system should consist of a hierarchy of modules. Lower-level modules are generally smaller in scope and size compared to higher-level modules. 2. Coupling. Modules should be loosely coupled. It means that modules should have little dependence on other modules in a system. 3. Cohesion. Modules should be highly cohesive. It means that modules should carry out a single processing function. 4. Span of control. Modules should interact with and manage the functions of a limited number of lower-level modules. It means that the number of called modules should be limited. 5. Size of module. The number of instructions contained in a module should be limited so that module size is generally small. 6. Shared use of functions. Functions should not be duplicated in separate modules, may be shared. Prototype. A prototyping approach emphasizes the construction model of a system. Designing and building a scaled-down but functional version of a desired system is the process known as prototyping. A prototype is a working system that is developed to test ideas and assumptions about the new system. It consists of working software that accepts input, performs calculations, produces printed or displayed information, or performs other meaningful activities. This approach is useful when the requirements are not well defined. A prototype is usually a test model. Prototyping process are: 1. Identify the user's known information, requirements and features needed in the system. 2. Develop a working prototype. 3. Revise the prototype based on feedback received from customer. 4. Repeat these steps as needed to achieve a satisfactory system. Joint Application Development (JAD). It is defined as a structured approach in which users, managers, and analysts work together for several days in a series of intensive meetings to specify or review system requirements. The important feature of JAD is Joint Requirements Planning, which is a process whereby highly structured group meetings are conducted to analyze problems and define requirements. Participants in a JAD session leader. The JAD leader organizes and runs the JAD. This person is trained in group management and facilitation as well as system analysis. The JAD leader sets the agenda and sees that it is met. The JAD leader remains neutral on issues and does not contribute ideas or opinions but rather concentrates on keeping the group on the agenda, resolving conflicts and disagreements, and soliciting all ideas. 1. Users. The key users of the system under consideration are vital participants in a JAD. They are the only ones who have a clear understanding of what it means to use the system on a daily basis. 2. Managers. The role of managers during JAD is to approve project objectives, establish project priorities, approve schedules and costs, and approve identified training needs and implementation plans. 3. Sponsors. A JAD must be sponsored by someone at a relatively high level in the company, i.e. the person from top management. If the sponsor attends any session, it is usually at the very beginning or at the end. Point 4. Systems analysts. Members of the systems analysis team attend the JAD session although their actual participation may be limited. Analysts are there to learn from customers and managers, but not to run or dominate the process. 5. Scribe. The scribe takes down the notes during the JAD sessions. This is usually done on a personal computer or a laptop. 6. Is staff like systems analysts. Other is staff such as programmers, database analysts, is planners and data center personnel may attend to learn from the discussions and possibly to contribute their ideas on the technical feasibility of proposed ideas or on technical limitations of current systems. Benefits of joint application development. 1. Actively involves users and management in project development. Point 2. Reduces the amount of time required to develop a system. Point 3. Incorporates prototyping as a means for confirming requirements and obtaining design approvals.